Hello, YouTube, and welcome to this week's episode of Brainstorm, where we give you a glimpse into the world of science. Our top story this week comes from the world of evolution, where a study from UC San Diego suggests that a single mutation may have been crucial for early human evolution. The mutation caused the production of a new form of a sugar molecule used for cell signaling, and occurred as Homo erectus was evolving about 2 to 3 million years ago. This change to the molecule gave our ancestors resistance to certain strains of malaria, but also made it difficult to interbreed with those without the mutation. This was tested by applying human antibodies to chimpanzee sperm, resulting in a response. Mice were also engineered to mimic this mutant-non-mutant dynamic, and interbreeding resulted in fewer offspring. The benefits of this mutation, coupled with the interbreeding complications, may have initiated our ancestors' divergence from other apes, ultimately resulting in where we are today. Our next story is exciting news from the world of medicine. Researchers in Japan have successfully treated diabetes in mice. Diabetes is caused by lost or malfunctioning beta cells in the pancreas, resulting in a lack of insulin. The researchers were able to create new beta cells from neural stem cells extracted from the olfactory bulb. These neural stem cells were exposed to two molecules that promote insulin production, converting them into beta cells. After growing on a collagen scaffold, the new cells were implanted on the pancreas of mice with type 1 and 2 diabetes. Within a week, the mice showed increased insulin production and lived diabetes-free until the experiment was ended. Hopefully, this new treatment can be applied to humans easily, as it has several advantages over other experimental ones, such as the accessibility of the neural stem cells and the ability to convert them without genetic manipulation. And from the field of material science, a team led by Stanford scientists have discovered a new form of carbon with similar properties to diamond. This new form was made by exposing another allotrope called glassy carbon to extreme pressures. The new carbon shows properties as good or better than diamond, being able to withstand 1.3 million times atmospheric pressure. This material's strength may be even greater than diamond. Because it's not a crystalline structure, pressure from any direction could be handled. If, after more testing, this new allotrope shows potential, there are a number of applications for ultra-dense materials. Our final story is an update from the world of physics. Engineers and scientists in Poland have designed a new kind of plasma thruster for space travel. Plasma propulsion is excellent for long, sustained thrust in space, as opposed to chemical propulsion. The problem is that the most common fuel for the plasma is xenon gas, which is extremely expensive. With only slight modifications, the thrusters should be able to use krypton gas as propellant, which is tenth the cost of xenon. The prototype krypton thruster is going to be tested in vacuum conditions before hopefully being used as an effective propulsion system for small spaceships. Well, hope you enjoyed this episode. If you did, please consider subscribing and be sure to check the links in the video description.